The material that I was going to talk about this week was distributed computing, which has a lot to do with cloud computing. So let's start on this first link here, distributed systems. I'll put this into our Slack channel as well. So some of the challenges of distributed computing, one of them is this concept of eventual consistency. And really the foundational infrastructure of the cloud is that it is designed so that eventually things will be consistent, but not necessarily they would be consistent at the beginning. If we look at a good example of this, this is DynamoDB. And in fact, if you really want to understand a lot of great material on cloud computing, this blog, All Things Distributed, is a great blog if you haven't had a chance to do this. But this is the CTO of Amazon, and he talks about this paper. And if you look at this, this is in 2007. And he said, in 2 weeks, we're going to present a paper on this thing called DynamoDB. Turns out that DynamoDB became a really important part of distributed system. But if we scroll down here, one of the things I'll talk about is that there's this concept of ACID with a traditional database, which is, atomicity, consistency, isolation, durability, and these are things that are traditionally in a relational database. But when you get into a distributed database, you have to actually have a trade-off here. And one of the ways that we go into this, and we'll talk about this in a second, is that when you get into distributed systems, you have to use other techniques. And one of them is that you have to be able to partition the data so that it's scalable. And one of the techniques that they use in Amazon DynamoDB is this consistent hashing. If you want to have high availability for writing the data, one technique that they use is something called vector clocks. And so the version size is decoupled from the update rates. What about handling temporary failures? They have a quorum, so they essentially have a group of different people, and they vote on how to actually handle something, and this provides high availability. They talk about how they can handle permanent failures, and also they can talk about membership failure and detection. There's a lot of detail in there that would be actually good to read, but I'll skip through and just kind of go to the next section here, which is this concept of a CAP theorem. So what is the CAP theorem? And let's maybe make this a little bit smaller. And why do you care about it? Well, this is really the premise of all of cloud computing, and especially in dealing with data, is that there's a trade-off of consistency and availability and fault tolerance, and you can't necessarily choose one over the other. You have to you can't have all of them at the same time. So if you want to have consistency, there's going to be a trade-off about availability. So a good example would be a relational database. Most of the time, a good example, let's say Charlotte, North Carolina, right, is a banking capital of the region. If they're doing something with a database, a lot of times they want it to be consistent because it's got financial data, but it's directly in conflict with availability, because if I'm writing data to a database, then people can't read the data until I'm done writing, right? So there's an inherent conflict there. The same goes with fault tolerance, that a system continues to function when messages drop between nodes, that's something that you have to have a trade-off with. So these are constantly in conflict, and typically you can only have 2 of the 3, not 3 of the 3. And then in terms of availability, this means that every request receives a healthy response. So this problem really presents itself with things like a relational database versus a key value database. Related to this is another theoretical concept called Amdahl's law. And with Amdahl's law, this really gets into this concept of diminishing returns with parallelization. Where you'll see this in action a lot is with your laptop, for example. If you go to a laptop that was in the early 2000s and you look at one now, one of the big differences is that your laptop now has all of these cores associated with it, so it can, run multiple things at the same time. But it isn't a free lunch. The more parallel you make something, the more you're able to actually, lose some of the advantages of it. So you can see here, if we go to, let's say, a 2-core machine, if only 50% of your code is parallel, then right after 2 cores, it doesn't really give you much of a benefit. Or if we go to, in the case of 95% speed up, though, it can take, once you get into, let's say, 16 cores or something, you've got the majority of the speed up, even if it's 95% parallel. So this is really another problem that you have to deal with in cloud computing, is that just because you can distribute something to a bunch of different machines, it doesn't mean that there isn't something you're losing as a result of that. Another concept in cloud computing that's very important is this concept of elasticity. And so what this means is that it's your ability to adapt to a varying workload. So you only are paying for what you're using. And this is an example of elasticity in action. Would be that, let's say you have a web service and it's Amazon Elastic Web Service. You go through here and you have 3 nodes that are there. Let's say this is a Apache web server that is a Python application. And it turns out that you're maybe doing a bunch of web requests around some kind of a post that someone did. And it turns out that there's more and more requests coming in, and then these nodes here, they'll start to get busy. Like, let's say it's 50%, 50%, 50%. Your load balancer, it can actually work with a scale group, and it can decide to automatically put another web service into the load balancer. And then this is the way that you get elasticity, is it's completely automatic and it's based on metrics. And this is a core principle of cloud computing, is that you have to have it, you have to have the capability. So if you have a physical data center, you can't do this. You can't just, magically out of thin air put a new machine in somewhere. But in the case of cloud computing, you can. And then second, it has to be automatic. Likewise, just because you scaled up doesn't mean you don't have to automatically have scale down capability. So once the traffic starts to diminish, one of the things that you can do is you can actually reduce the nodes by taking away this node as the traffic actually goes down. So a very important concept in cloud computing is this concept of elasticity. Now let's talk about the high availability concept. That again goes back to the CAP theorem a little bit, but does your system always respond with a healthy response? And how is high availability different than, for example, elasticity? Because they're 2 different concepts. Again, elasticity just is, can your system respond to the load and add a node and remove a node? But high availability is a different concept in that it means that, is your system always able to respond with a healthy response? So a good example of this would be Amazon S3. So if you're highly available and you have a 9.9 system, your yearly downtime would be 31 milliseconds. So in this example, let's say this is the architecture for Amazon S3. You would have a region here, A, you have region B, region C, and you have something not only at maybe the load balancer level, but you have a global load balancer, and it's able to actually distribute the traffic based on each region. And if an entire region goes down, it could continue to send traffic out. And so high availability is less talks about how you got there. Elasticity is how you do it. High availability is it done, right? So how would you build a system where throughout a whole year it only has 31 milliseconds of downtime? Is you have to think through the architecture and make sure that you've planned for failure, and you've made sure that no matter what happens, the system has enough built-in capabilities to it that even whole regions going down won't affect the availability. And that is how actually Amazon's Elastic S3 service works. Now let's go to the next topic here. So those are just some of the core concepts, but let's go into elastic computing with notebooks. So most data scientists really are at some point going to be doing things with Jupyter Notebook. And one of the things to be aware of with Jupyter Notebook is that it really is the central hub for dealing with cloud computing. So you can do things like do data science, right? You can build projects and figure out housing prices and do predictions. You can do visualizations. You also can share things like if you use Colab Notebook, for example, you could check it into GitHub and share it. And also I just talked about that, the source control becomes part of it. So this is really the science focus of a Jupyter Notebook. But what's less talked about is with cloud computing that Jupyter Notebook is actually heavily integrated with engineering as well. And that's one of the things that we're going to get into is talking about how you can build Jupyter Notebooks from scratch, and we're going to walk through a whole project there. So you can do machine learning training with Jupyter Notebook. You can do machine learning deployment. You can also communicate with the data lake. You can talk to GPUs. You can have Docker format containers. And you can also have a hosted version of Jupyter Notebook. So let's walk through some of the stuff that happens in a typical data science project and then how it applies to the cloud. So step one, you could first ingest the data. Maybe it's a CSV file, maybe it's a SQL query, maybe it's a data lake. Step two, you do exploratory data analysis. Step three would be modeling. And then step four would be a conclusion. And if you're going to check this into GitHub, for example, when I recommend someone creates a portfolio, I would recommend you create something like this: ingestion, exploratory data analysis, modeling, and then conclusion. And then this in particular is a DevOps workflow for Jupyter Notebook. So this is an example of a popular technology best practice, and it's often used with Python. But here's how you could apply DevOps to Jupyter Notebook. Workflow is you have a notebook, let's say it's Colab Notebook or it's a Sagemaker Notebook. You check that into source control. You have a build server that automatically knows that the notebook is there. It takes an action where it builds out the notebook, and then you can do a test. And the test is either going to pass, and in that case maybe you would deploy, and then that notebook would go into production somewhere, or you could actually have a fail and you would have a report. So this works a lot like traditional source code. So let me just show you briefly here what that would look like. So if I go to this project, which is GitHub, my repo, this is actually a pretty good example, and I'll put this into a messaging system here. It's a pretty good example of a Colab Notebook / Jupyter Notebook workflow. As you notice, I have a notebook here called notebook.ipynb, and I do some really simple things inside of this notebook, but I can actually test the notebook by creating a makefile command that runs this python-m pytest nbval notebook.ipynb. And what's great about this is I also can go to a build system. In this case, it would be Circle CI, and I can tell it to do a make test command, and it will also run the test inside of the build server. So I also can treat notebooks like source control or source code. And so if I click back to here and I go to the badge that I've got created here, here's a badge, you can see from the last command what it looks like when you actually run this notebook successfully. So if I click here, we can say run test, and then you see that this command python-m pytest nbval notebook, that it'll actually go through and cell by cell execute your code. So this is, I think, it's not done as much as it should be done, but you can treat your notebook as source control. And I'll explain in a second why that's important. So let's look through again the basic structure here is that potentially you could have a Docker file if you wanted to, and you put some things inside of there, and maybe you even launch your Jupyter Notebook inside of something like Cloud9 or on an EC2 instance. But what is the DevOps workflow for Jupyter Notebook would be that you have your source control system. And again, this is one example where you have a make file, you have a Docker file, you have your plugins. And in this case, this is a NBVal, which is a particular plugin for PyTest that will test Jupyter Notebooks. You have your Jupyter Notebook, and then you have your packages. And what's great about this is that you could then deliver a data science project to somebody, and you've already tested it as well. I believe many people have had experiences with Jupyter Notebook where someone gave you a notebook and you can't run it because all the packages are impossible to find. You can't figure out what they did. This is a way of controlling that, as you treat the system, the Jupyter Notebook, like source code. And then again, to run it, this is an example, Python-m, PyTest. So now let's talk about something that's more production oriented, and this is really getting into large scale machine learning or machine learning engineering. Machine learning engineering is that this in particular, let me just make this a little bit bigger and just focus on this. This is an example of a project that we're going to walk through step by step, and we're going to build this out, this entire distributed system. And the way it works is by, again, focusing on the data science workflow here of you have ingestion, and we're going to retrieve data from AWS Data Lake. Step 2, you have exploratory data analysis. We clean, visualize, and scale the data. Step 3, we do modeling. We just do distributed modeling tasks, and then we create these clusters. And then 4, we do a conclusion. So this is just a Jupyter Notebook, but what's powerful about it in AWS is that you can provision this notebook, and then you can actually go in and grab the data from our data lake. And this, we talked about this previously, the Amazon S3 is a data lake. It has infinite compute, infinite storage. And once we get in there, we can do our exploratory data analysis steps. These are typical things that data scientists do: drop missing values, create histograms, scale the data. Once we've done that though, then we spawn a couple of distributed computing jobs. So this goes back to those concepts we just talked about: elasticity, fault tolerance, where I actually tell Sagemaker to create a bunch of nodes. In the background, it'll spin up a bunch of machines to do a distributed machine learning training job. If I had to do this with scikit-learn or some other framework, this would be very difficult because they're not designed to work on distributed computing, but Sagemaker is. Second, I could also do 2 different machine learning jobs at the same time, and then when they're done training, they would put the trained model back into S3. So that's another really nice thing about something like Sagemaker, is it'll put the output back into S3 for us. And then now if I want to deploy this, let's say I'm Netflix or something like that, and I want to deploy a clustering model to production and I want it to be deployed globally, well, you could use something like Sagemaker again, and Sagemaker would spin up a cluster of endpoints. And then these clustered endpoints will actually go back down and they'll talk to the S3 bucket. So this is an actual project that we're going to build step by step, and this is the picture. So it may be helpful. You can go to this, go to this link here, noagif.github.io, cloud data analysis at scale topics, elastic machine learning with notebooks, and refer back to it as we're building it. So let's go ahead and build this. I'm going to go into Amazon now, go into console here, and I'm going to go over to Sagemaker. And from Sagemaker, let me just give you the 5-cent tour here. One of the nice things about Sagemaker is, if again going back to this diagram, is that it's more than just a notebook. It's an entire ecosystem for doing distributed machine learning at scale. And so what we're going to do in this case is create this whole diagram, and let me just show you how that relates to the console itself. The first part we won't touch, but that's ground truth. And if you needed to label your data, let's say you're a manufacturing company and you had 1,000 products and you had maybe 1 million pictures of those 1,000 products, you could upload those all into Amazon S3, click a button, and it would create a labeling job for you, and it would farm that out to people all over the world, and they would put the labels on it, and then you could later then train a computer vision model. We're going to mostly focus on Notebook here, training, and inference. And the Notebook is just the hosted environment. The training is where we do distributed machine learning. And the inference allows us to create models from training data or import external models for hosting. You also can look at those on these tabs here. And these are, what's really great about this as well is that they have a search dashboard that allows you to search through existing jobs. So here's an example of, let's say I search down for job status, training jobs, and I look for equals, and then I say, let's say completed, and I can search and I can find all the training jobs that I completed, in the last, for the history of Sagemaker, and I can even find their location inside of Amazon S3. So this is another capability that is really not, it would be something you would have to build yourself if you were working with something like scikit-learn or R, using one of their open source tools. They're not designed to work at scale. So let's get into the Notebook section here. I'm going to click on this icon, Notebook instances. And what I'm going to do is I'm going to create a new notebook from scratch. To do that with Jupyter Notebook, what you would do is you would say whatever name you want to call. So we'll just call this Census Screencast here. And by default, really, this is not that important, the size of your notebook, because most of the work with Sagemaker is done outside of Sagemaker. It talks to other parts of AWS. This is another thing to be aware of, is that if you wanted to do GPU-based training on the machine, you can install these elastic inference endpoints, but we'll just leave everything by default. And then from here as well, here's an example of how you could set up permissions. By default, Sagemaker allows you to talk to other Sagemaker components like distributed training and also to S3, but that's it. If you needed to do something outside of this, like let's say talk to AWS Lambda or talk to maybe a computer vision API or do some general purpose software engineering, you would have to go through here and then go and create a new role and then assign that new role. But we're going to leave it the defaults. We don't need to do anything special here. And then also this section here would be where you could decide whether you wanted to give users root access to the notebook itself. And then finally, in this section, this is something to be aware of, is that if you're working with sensitive data, it's a requirement in most organizations that you would encrypt your data automatically. And so this is typically a good best practice to have. You also could check out a repo. So if you already have some source code, you can just check it into Sagemaker, which is pretty handy, right? So then we can go back to that virtuous cycle, what I talked about, which is your notebook could be checked into let's say a private GitHub repo, it could be tested, and you could make sure that you're validating the quality of your source code. So we're just going to go ahead and say create notebook instance here. And because I already created one earlier, just to save time, I'll just leave that one alone, and I'll go to another one that I did. I'm going to click on Open Jupyter. So once you're inside of Jupyter, a couple things to be aware of is that on the right here, you see New. This is where you could actually go into different kernels. So you could run R if you wanted to. You could run Spark. You could run Amazon MXNet. You could do Python, PyTorch, TensorFlow. You also could spawn a terminal. So here's an example of a terminal. So if you want to, you can just start, doing Python 3, import os.system, just start using it as a general purpose programming environment, as well as, something that can that can do notebooks as well. So I do sometimes do this when I'm using SageMaker. Is I'll navigate around to the file system, maybe look at how much storage is on the device, so it's, or I could run a top command, right? I could go through and see what's physically occurring on the machine, what's taking up memory. So there's a lot to like about knowing that you can run a terminal right on the notebook environment itself. But what we're going to do is, instead of creating a new notebook, I'm going to use the SageMaker example notebooks. And let me just briefly show you about all these collections of samples. This is really the way to master SageMaker, is to look through these different sample notebooks. And there's an example potentially of every single kind of thing that you would ever want to do, like Amazon algorithms, machine learning algorithms, hyperparameter tuning. So SageMaker can pick the parameters like the number of k-means clustering nodes to select, or reinforcement learning, PyTorch, ground truth, autopilot. Basically, you name it, there's an example of how to do it inside of here. We're going to focus on introduction to applying machine learning, and we're going to go to one called SageMaker County Census Clustering. So I'm going to select this button right here, Use. And what it's going to do is it's going to create a copy, and it's going to put it into my environment. And again, this is for any notebook. This is what I would recommend, is do that copy mechanism, and then execute the examples step by step. So let's scroll through here and talk about what this notebook is. So this is a notebook that explores the 2018 midterm elections. And this is very similar, this workflow, to what a data scientist would do in the real world. That's why I selected it. And in the real world, a lot of times the data is messy. You have to clean it up a little bit. So in this example, the author of this notebook has gone through the census data, and they've actually saved this census data inside of S3 for us. So the goals of this, we're going to walk through using SageMaker, and we're going to go through and set up principal component analysis and also k-means clustering. The data science workflow, this person also agrees with me that there's 4 steps: ingestion, loading the data; step 2, exploratory data analysis, which is cleaning the data, visualizing the data, doing feature engineering; step 3, modeling. So in this case, the model is going to be an unsupervised machine learning model. So dimensionality reduction, and then principal component analysis. And then finally, drawing conclusions from our model. So let's scroll down here, and let's do step 1, which is loading the data from Amazon S3. And again, if we go back to this notebook here, or to this picture, this is the data lake, right? So this is the heart and soul of cloud-based machine learning, is you have to communicate with Amazon S3, which is the data lake. So I'm going to go back here, and I'm going to run this first bit of code, and maybe I'll make this slightly smaller. So let's go here and type in shift return, and you'll see when it's executing in SageMaker, there'll be a asterisk right here, and this asterisk means it's kind of waking up, and it's running that cell for us. And in some cases, when the code is taking a long time to run, it'll be running. It could take 10 minutes, depending on what it is it's actually doing. The first time it just takes a little bit of time to wake up. And now this is where you could verify your execution role. And this is where you would, if you wanted to do something beyond just talking to S3 or talking to SageMaker, you would have to verify it and look up what this role actually is doing, and maybe assign it more privileges. So let's go ahead and load the data from the data lake here. This is a publicly available bucket. I'm going to use the Boto3 interface here and load this in. Here we go. Next up, I'm going to print out the name of the file that's in that bucket, which is census data for SageMaker. I'm going to then grab this data from the bucket. And now that I've got it into a pandas data frame right here, you can see this is a good example, by the way, of how to understand how to develop against Amazon. The API would be to look at something like the S3 bucket here, call, and then see how they convert that into a data frame, and then they use this head operation and they print out the raw data, right? So we can see this is the census ID, this is the state, this is a population. Next up, now that we've got the data, let's get into exploratory data analysis. So we're now in phase 2. Again, going back to this diagram here, this would be, this is phase 1, grab the data. Phase 2, exploratory data analysis, we need to do things like handle missing values, do histograms, scale the data. So let's look at the shape. This is always a good first step. How many rows are there? 3,220. How many columns? There's 37 columns. I always do this the first time I deal with data. And then let's make sure that we drop the missing values. So most machine learning algorithms are not happy when you have missing data. So we'll go ahead and we'll drop these. And now look, you can see that we dropped 2 rows, right? And another thing that is very common is that when I'm dealing with regional data, a lot of times I like to create a hybrid column so that it's easier to understand what's happening. So in this case, what we do is we scroll through here and combine the state and the county so that it's easier to look at the data and see that, okay, that's the county in Alabama, right? Because sometimes the county names could be the same names. Okay, now that we've got that, let's do some visualization. And so what this is going to do is visualize the distribution of the different types of professions in a particular region or county. So in this county, I believe this is actually for all counties. Yeah, this is for all counties. We can see that the median is right around 30% of people are professional workers. And then across the United States, and about 18% are service workers. And then the median is, let's say, 22% of workers are office workers. So next up, what we're going to do is we're going to do feature engineering, which is we're going to scale the data so that our unsupervised machine learning will work well. So almost all machine learning algorithms, except for a few things like linear regression, you have to scale the data before you apply the technique. So we use scikit-learn here, since we've already got the data into a data frame, and we run the min-max scaler, and then we apply that to the data frame. So we'll go ahead and run that. And then if you want to look at it, you can see that in fact it converted everything to the same scale, right? Everything's now between 0 and 1, all of the columns. Now that we've got this set up, the next step would be to actually do the modeling. So again, we go to this picture, we just did this. Now what we're going to do is we're going to provision out a cluster of machines and spin up a bunch of nodes to do a bunch of distributed workloads. And then later, it's going to write the trained result back to S3. So let's go ahead and do that. Let's go to this next section. Now, this is an important part of working with something like Sagemaker, is that I'm going to have to tell it where I want this data. So it's up to me to put the output, right? Because again, we want to put this data into S3 here. So I'm going to go back to Amazon, and I'm going to go to S3 here, and I'm going to create a new bucket, and we'll call this Census Demo February 15th. And I'll just say next. Now this is important too. Make sure you're in the same region as Sagemaker. In this case, it's North Virginia. We'll just create this bucket. All right. Now that I've got that, I can look for Census Demo February 15th. This is our bucket. Let's just copy this name here. Let's copy this name. And then I go back to this section, and I just paste it in here. There we go. Census Demo. Now from here, I can execute that cell, and then it's literally one line of code to set up this giant distributed machine learning job. In this case, we only have 3,000 rows, so it's not that important. But what if we had 3 billion rows? Then it would become more important. Notice here that I can say train instance count. I'm going to, for fun, say 3, just to kind of make it more interesting. And then I also, if I wanted to, I could change the kind of instances, right? I could give it GPU instances to train. These are regular CPU instances, but you could give it specialized machines. We'll go ahead and run a shift return here. And then all this does is prepare the data so it's in the right format for SageMaker. This is more like kind of boilerplate code. And then now we run the fit. And the fit, what it does is it spawns these 3 nodes. So let's go ahead and do that. Let's do a shift return. And this will take just a second. This will take a few minutes. I think it maybe takes like 3 or 4 minutes. And now let me show you how to actually observe what's happening. Again, let's first look at the diagram. If we see here, we told this thing to spawn, and what's going to happen is it will, however many workers we told it to spawn up, it'll spawn them up. And the other thing that's great about it is that it's a distributed machine learning algorithm. So we're using a web scale distributed algorithm that can handle and scale out to many nodes. And also it'll remove the nodes when it's completed and automatically put the data into S3 for it. So it does a lot of the heavy lifting for us. So what I'm going to do next is I'm going to open up a Sagemaker tab here. I'm going to go to Sagemaker, and I'm going to show you how we can take a look at what this thing is actually doing. So if you look at this training tab now, we can click on training jobs, and look, you can see that this one's actually in progress. And this is one of the benefits of using a system like Sagemaker, is that it shows you the ability to, it shows you exactly what's happening when you launch these jobs. So if I click on this, you can see all the different things about what all different things about what it's doing. So it's going through here, starting the job. It shows you what time the job started, also what the algorithm is. In this case, it's running a principal component analysis job. And then it even shows you how many instances are associated with it. And also, what it will do when it's done is that it will show you where it actually will put that model. Another thing that it'll do as well is it gives you access to look at the algorithm metrics, the logs, and the instance metrics. So let's take a look at a couple of these. So if we look at the instance metrics here, you can see here these are the training jobs, and when those populate, they'll populate there. If I look at the logs here, what this will show you is the actual log files. When the machines spin up, they'll start to tell you, what's happening with that training job. So you can completely monitor the process of this thing spinning up. Also, if you go to the foreground of Sagemaker, it will show you line by line exactly what it's doing. We can see this is starting the training job, launching requested machine learning instances, downloading the input data. Now, after the model is created, and again, this will take a few minutes here, we can actually get into it and actually inspect what it is it's actually did. So here we go. It's downloading the input data, uploading it, and notice that it's behind the scenes actually using Docker for us, and it goes through and it tells us all this information. Now, if we scroll all the way to the bottom here of this output, you can see that it's currently running, and it shows all these metrics. So I can go back to Sagemaker, and if I look at these log files here, something should be populated. There we go. Look, we can see each of the 3 nodes, right? Here's algorithm 1, here's algo 2, here's algo 3. And if we look at it, it tells us exactly what it's doing. It tells us that every single component of what it does. So this is another really powerful thing about doing distributed computing on a platform like Sagemaker, is that every step of the way you can figure out what's happening. So once it's done, then it shows a complete, and you can see that it took a total of wall time of 3 minutes, but the actual training was completed in 600 milliseconds. And I believe that's because we ran it against multiple nodes. So it took a little bit of time to launch the machines, but then the actual training job was under 1 second. Okay, so next up, we can access the model attributes. So we're going to go here and do shift return. And what it's going to do is going to grab that trained model out of the S3. and then we're going to load it into an array. We're going to use the MXNet library. And then what we're going to do is we're going to throw away some of the noise because there was 30 something columns and we're going to only keep a few. So we're going to kind of clean this up a little bit and then calculate the top 5 components that have most of the variance in the data. So that's the whole point of principal component analysis, is you kind of shrink things around so that you have less components to deal with. Let's go ahead and do that. And now I can go ahead and print this. And this will show us that this is one of the components here, that it's negatively correlated with white demographic and positively correlated with Hispanic, and and then also shows the different kinds of work that this component does. So next, we can go through here and actually put labels to things. So this is a lot of times what's as a data scientist you would do is go through, and when you create a cluster or create a principal component, is label it so that you understand what it does. So like maybe this cluster here component is got poverty and unemployment. This one is self-employment. This one be high income, and then maybe this one is construction and commuter, right? So let's go ahead and do that. Let's do shift return. And now we'll go through and we'll actually deploy this model to production. So in this case, let's just make it a couple. So let's give it two endpoints. So it'll be able to distribute the load across both of these endpoints. And so now this will take actually quite a while. It'll take about 10 minutes. But basically what this will do is it'll provision this so that it can be run in production somewhere. So if I go back to the diagram here, you can see that this k-means clustering algorithm, the principal component analysis algorithm, we've already done this step. The next step is that we are launching a distributed principal component endpoint, and we're going to tell it to serve out this model that lives here. And let's go back to Sagemaker while this is running and take a look at what that would look like. So where would we see this? Well, we would see this in the inference section. This is what this picture is right here. These are inference endpoints. And if we go to inference, you'll see that they'll show up under here, under endpoints. There we go, and you can see that this is being created. And if I select it, what will happen here is that it will show me a bunch of metadata as well. Like once this thing is fully spun up, we can see the logs, we can see how many people are calling it. So this could be potentially, depending on what the problem that we're solving is, we could be done with our project and we could be deploying this to production, and then part of our company is now using the machine learning model that we created. It's really that straightforward. The other thing to be aware of though is this thing is runtime settings. Is you can decide how much weight you want to assign to one endpoint. So you could try, let's say 3 or 4 or 5 different models, and then maybe weight a third of the traffic to one model, a third of the traffic to another model, and a third of the traffic to the third one, and then figure out which one of them is performing best for your company. Let's say it's a consumer products company and you're selling things. Well, you could shift all of the traffic to the endpoint that has done the best, and then you could actually decide to keep that model and make that one the production model. And again, the reason you can do this is that you can provision as many of these endpoints as you want, right? So you can go through here and decide that you're able to actually try lots of different experiments. Because you have this distributed computing infrastructure at your fingertips, and then you decide which of the experiments that day you're going to keep, and then what's great is that now that it's running in production, you don't have to do anything else. You're pretty much ready to go. So that's kind of the high level architecture. Again, the first time you launch these instances, they do take a little bit of time. I think it's somewhere between 10 to 15 minutes. For each one. So what I'm going to do is I'm going to just execute the rest of these cells so that we don't get hung up on this, and then I'll come back and explain them. So I'm going to run this, run this. I'll just keep running these things. And then I'll come back and explain what they do later. Let's run that. And that's another thing that's kind of fun about this, is that you can kind of queue all these cells up and then later come back to them. There we go. So while this is running all these different nodes here, what I'll do is go back to SageMaker and explain some of the things about SageMaker and what it does. So let's stop right here. This is where I'll want to come back to, is right there. Okay, so if I go back to SageMaker here, let's now get into this workflow, which is training, notebook, training, and inference. So again, one of the things that's helpful about a platform like SageMaker is if you go to the search icon here, you can select these different properties, and you can look at different things like last modified, training start time. In this case, I think one of the better ones is training job status, and we can see which ones have maybe completed recently. And let's say I'm a data scientist at, again, Netflix or some huge company. I could actually use this to spin up hundreds of models in 1 hour, and then come back here and look at the ones when they're finished, and then actually start diving into those models and even looking at them on disk. So this is the one we just created. What I could do is I can actually go back to S3 here, and let's refresh this, and you'll see that in fact now there's something here. And what this is actually the raw file. So what I'm going to do, just because we have some time to kill here, is I'm going to download this locally, and then what I'm going to do is I'm going to go to Cloud9, and I'm going to look inside of this. So let's go spin up a Cloud9 instance here, and let's just take this one. I have a Cloud9 instance already available. And what I'll do is I'm gonna now show how you can use another cloud instance to kind of reverse engineer what's happening inside of SageMaker and figure out what to do with this trained model. So here we go. We have an environment here. So I'm going to go to File, and I'm going to say Upload Local Files, and I'm going to say Select, and here's that model. I'm going to go ahead and do this. Now that I've got that model, I'm going to stop this and do an ls. And I believe it put it into this project, this Docker Flask project that I was working on. So I'll just move it up one directory. Let's see, yeah. Okay, so now I can go through here and I can run this command called tar zxvf, which basically says just uncompress this thing for me, like that. And then when I look inside of there, you can see that now I can view what's inside of this project. So here it is. It says model algo, right? So let's go ahead and see what's inside of here. It's not a directory. It looks like it's just that's the raw file here. And if I cat it, it's going to be in a kind of a serialized format, right? You can see that it's a serialized model. So what I could do is I could actually reproduce what SageMaker was doing itself, and I can do it locally here. So why don't we try to do that? Let's see if we can run some of this stuff and see what it was doing. I think it did this. So it said it downloaded it, and then it said import MXNet. So let's try this out. Let's see if we can do the same thing here locally. Again, we're just kind of playing around here and seeing what we can do. So I'm going to create a virtual environment. So say Python 3, and we'll just call this SageMaker Fun. I will source it. like that. And then I will do a pip install of MXNet if I didn't already have it installed. And then in theory, I can do the same thing Sagemaker is doing in their notebook. I guess, sure, let's just upgrade this. It's pretty irritating. Pip install -- upgrade pip. Okay, let's do that so I don't hear that anymore. Okay, so next I can run IPython. Oh, well, let's install that. Pip install IPython. I like to use IPython when I'm experimenting with things, so we'll go ahead and do IPython, and then we'll paste that. Import mx.net, great. PCA, well, that looks like it works. So what's cool about that is I can actually also play around with this model later. I don't have to necessarily use Sagemaker. Once Sagemaker creates the model, I could then even take it and convert it or use it in like a Flask app and deploy it later. So that's a very interesting workflow to be aware of. And so next up, let's do the same thing they're doing here. Let's just run it in another shell. There we go. So, oh, I need to import pandas as PD. So let's import pandas. I'm gonna probably have to install that as well. So I'll say pip install pandas. Okay. So import, we'll say import pandas as PD. There we go. Now it works. And then next up, let's see what else Sagemaker has been up to. Let's go here. And we'll look at the 5 components that explain 72% of the variance. Okay. There we go. So basically, I can completely recreate. There's nothing magical about Sagemaker. In fact, I even could do the API calls myself that it's doing and spinning up all those nodes inside of Cloud9. So it's just something to be aware of, is that there's lots of ways to even interact with Sagemaker by calling out its APIs. And then next up here would be if I wanted to, play around with more stuff. And I'm just going to leave this as is, just because we've explored enough that you can play around with this data and explore it in another environment. And if later I wanted to convert it to, again, like a Flask app with scikit-learn, there's some ways I could do that. So that's one thing to be aware of. I'll go ahead and just maybe close this for now. And if we go back to this notebook here, one of the things that we can see is that when it deploys the model, you can see that it will also tell you the length of time that it took. In this case, it was 10, and we have initial instance count of 2. So again, let's go back to our diagram. We'll see what it's doing. It's on this step. It spun up. In this case, we didn't do 3, we just did 2. And then it's going to host this model right here. So how do we see this in action? Well, we can go back to the inference, and we can look at the endpoints. And if we look at this endpoint, we can see that this is ready to serve out data. So again, this could be a production scale machine learning system. And then we also get all this metadata about what is happening. And we can look even at the metrics around the performance. So we see how well the CPU is doing, how much memory utilization, disk utilization. We also can look at the logs as well. So this endpoint here, we could go through here and see all the different things that it's doing. And then another thing to be aware of is that, again, this is what I mentioned before, is that this is where we could actually update the weights, and we could actually decide that we have lots of different model variants that we're trying out, and we could put some of the traffic to one of the model, some of the traffic to another of the model, and really do like an A/B test of it. So lots of power that you get by using this built-in Sagemaker endpoint. Now this is an online system right here, so you can see that this is always running. But another thing that you can do with Sagemaker as well is that you can also do a batch transform job. And so what this would do would if you did a batch transform job is you would just give it the model. So in this case, maybe I would give it that model, and then I would tell it what kind of instances, and maybe I would say, 40 of these. And then what would happen is I could run it all once and then also do a large scale distributed training and then put that somewhere. So and then this would be the input data, and then I believe the output data. So you don't always have to do a online version where it's always running in production. You also could do a batch-based job and do a nightly version of it as well, or an hourly job as well. So next up here, let's probably just check through and see the other parts of the code. So here's our result. Next, we'll go through here and we'll look at this data and we'll look at the principal components, and we can see that for these principal components that we labeled, remember we labeled this is principal component 1, principal component 2, principal component 3, principal component 4, principal component 5. We can see how much of each of the components is associated with for each county that's inside. So basically, this county, how much of it has this principal component? This county, this is negatively. Now in this particular situation, we can see that it's positively correlated with this public workers. So next step here is we're going to now build clustering on top of those principal components. And so the way we're going to do that is we're going to again spin up another training job, but this training job will actually use our existing model. So here we go. We can do a k-means clustering algorithm. You can see that I already ran this, so it's complete. And you can look at the result is that it took a total of CPU of only 478 milliseconds, but wall time was 3 minutes. And now the next step is that we're going to take this k-means clustering model and we're going to deploy it to Amazon. So again, if we go back here, we're on the final step, which is we're going to have a k-means clustering endpoint that is able to serve out the clusters for our data. So this should take just a second here. This is probably on its way. So one of the things I can do as well is go back to Sagemaker here, and let's look at all the different things that we've got cooking. So we've got one notebook, or this is the notebook. I'm gonna take this one, what I spun earlier, and just save some time and show you what to do with other notebooks. So if you want to stop a notebook, what you can do is go through here and say stop, and this is how you stop it. And then later, if you want to delete it, once it's stopped, you can delete it. So I'm going to go ahead and delete this one, for example. Go through here and delete this notebook, and then I go through here and delete this notebook. One thing to be aware of is that if you are doing a lot of work with Sagemaker, you probably do want to just stop it only and then reuse it, because then you don't have to recreate a notebook and recreate everything you're doing again. This can be a pretty good workflow, is do what I did before, is just go through here and make sure it's in stopped mode. But if you're just playing around with something, then probably you would want to go through and delete it. Another couple of the things I'll point out while this thing's still training is that you also can do lifecycle configurations. So what you can do is you can say create lifecycle configuration, and you can just run arbitrary code every time the notebook is started, or every time you create a new notebook. So if you look at an example of some things that someone could do, here's an example of this. Let's take a look. Here's some scripts here. Automatically stop the notebook once it's been idle for more than an hour, right? That would be a way of maybe saving some money. Connect to an Elastic MapReduce instance, right? So this could be, if you're working with Spark a lot, this could be an example of something you could spin up here automatically. So a bunch of different workflow things that you can do as well with Sagemaker. So let's go back here, and that's the configuration. I already mentioned that with Git, this is one of the Git projects that I'd set up, but you can check out your source code automatically so that you can read and write bidirectional data to GitHub. Training, if we go to training, we're mostly been going on training jobs, right? And you can see here, these are all the jobs that have been complete, and it shows me when they were run, and I can look at more data about them. But two other things to point out is that you also can find algorithms from the marketplace. So basically, like buying an app, you could basically find, this is kind of the app store for algorithms. So let's say you wanted to do AutoML. You didn't want to write any code yourself. You just want to have something else do the training for you. You could click on this, and then you could subscribe to it, and then you could use their AutoML solution inside of Sagemaker. So this is also an emerging use case here, and you can see, what they would charge you. In this case, they don't charge you anything because they're just trying to evangelize their software. But in some cases, there are people that do like, maybe have their own proprietary machine learning algorithm. And let's just look at this one. If we look at pricing, you can see that they charge you $4 per hour. So in a way, this is like renting a data scientist, and you could actually put the experience of some other data scientist into your company by using these models. Let's also get into the hyperparameter tuning jobs. So this is another part that you can do is if you click on create hyperparameter tuning jobs, one of the things that you can do is you can tell the SageMaker itself to automatically pick the right parameters for your algorithm. I think a very easy one would be k-means clustering. You could say, I want you to determine the correct number of clusters, and it'll do it automatically for you. Let's see what else we got here. In terms of inference here, another thing that you can do, besides just the stuff we've been doing is we're creating these models here, is that you also can go to model packages, and you also can find pre-trained models that already have been trained for you, and then don't even write the code to train it, just use somebody else's. So here's an example. Let's look at some paid ones only. Here we go, deep vision vehicle recognition. So this is some company that is building out deep vision systems, and what they're doing is they're giving you the ability to do predictions on vehicles, and you just pay for it. So you pay, in this case, $2 an hour to do online, $126 online, or you can do batch transform. So you can actually do these batch transforms, and so it's again a lot like the marketplace approach to buying an app to solve a problem. Is that it's a way of renting the expertise of an advanced level data scientist inside of your company. So that's the models, and then the other thing you can also do is there's some augmented AI things where you could do worker task templates. So you could go through here and figure out ways of augmenting your task by doing these, basically the combination of people plus code. That's a lot of the solutions here, like Ground Truth does the same thing, where you can go through here and you can create a labeling job that goes through, and it uses both human workers and it uses the algorithms to figure out how to solve a problem for you. So there's essentially this vast ecosystem of SageMaker, and you can see here we got Ground Truth, notebooks, training, inference, and the marketplace, and really you can use some or all of those things in an ML project. So we'll kind of wrap this up with this final part of the notebook here. Is once this thing is spun up, then what will happen is we'll be able to go inside of here and use this endpoint to do our cluster prediction, and then figure out exactly which cluster a particular county lives in, and then also get into doing conclusions about exactly what's happening. So I guess what I can do as well is just kind of while that's running, just talk through again this architectural diagram here, and really what's important here is just explaining the difference between what this does and maybe something like Cloud9. So what it's a good observation is, what's the difference between Sagemaker and Cloud9? So what Sagemaker is it's a system that is a notebook-based development environment that creates a whole distributed computing infrastructure. So if you were, example, Netflix, that would be a good example, and you wanted to deploy a machine learning model at scale that worked on everybody in the whole world, you could use something like Sagemaker to work through the problem, spin up a distributed machine learning pipeline with maybe using one of those approaches that we described, and then putting the data into S3, and then telling Sagemaker as well to provision a whole cluster of machines that serve out this model. And in fact, what we can do is, let me go to Cloud9 here real quick, and I'll draw a difference between what problem does Cloud9 solve and what problem does Sagemaker solve. So let's kind of go into that. That'll be a good segue while we finish the training here. So let's make a new notebook here, and what I'm going to do is go into Cloud9. So we got Cloud9 here, and then we've got Sagemaker. So Cloud9 really is basically a cloud IDE, and so typically what you would do in here is you would do like software engineering tasks, and then with Sagemaker, so basically inside of here you could maybe build a web app, or create a container, make a Docker container, or maybe do like a serverless, build like an AWS Lambda function. But in the case of Sagemaker, this is really a distributed computing platform for machine learning. So distributed ML platform. So its job is really, again, it goes back to the focus. If we go to this diagram here and we scroll back up here, this is what Sagemaker does. Is it's a central hub that it does all these different things. It does machine learning training, it does machine learning deployment, it can interact with the data lake, it can interact with GPUs. So Cloud9 is really just a cloud-based development environment that is a general purpose shell that I can do things with, but Sagemaker itself has the ability to work at a much larger scale here, and actually create an entire ecosystem of distributed training and also hosting the model. So that's really the big difference. So let's go back to this now. We can see that it took a little bit of time. Now we can do these predictions. And then from here, look, we can see the cluster counts here, where we can see that this cluster has 1,000 members. This cluster has 630 members. And now we can actually print this out. You can see that this is the histogram of which counties are in which cluster. And this county is in this cluster. So in this county, the smallest cluster is this county. So typically what you would do next is you also would probably label this cluster, the K-means clustering cluster, and you'd call it something. And then from here, what we can do is, if we wanted to, we could download this model. Let's see if this works. Load this, and then let's see if this works. There we go. And we can look at the cluster centroids. And we could see essentially like the center of the cluster, what's the makeup in terms of principal components. And then you could plot through here and look at the visualization. So you could see that this cluster, for example, cluster 3, has heavy commuters in it, right? We'll kind of lead with that. And then maybe this cluster has, in fact, this construction and commuters principal component, you can see that in fact cluster 3 is like mostly the whole thing is construction workers and commuters. So okay, now how do we use this? Well, let's go back to the counties, and now let's go ahead and look for counties and see which cluster they're associated with, right? And so what we could do is we could filter by let's filter by cluster 3. I think that's one of the more interesting ones, right? Because we know that this one is mostly construction and commuters. So let's go through here and let's print out these 5 components, and we can see that Yuma, Arizona is basically a construction and commuter town, right? We know that that's probably the makeup. And so we also look at Fresno as well, or in this case, look at this, Imperial County of California, which I think is like a desert area of California. We got 88% of that is construction and commuter. So these are all, maybe one, if you were a political scientist, maybe this is a way that you could go through and you could create targeted ads that looked for, sends a message that would really appeal to this particular demographic. So really that's it. That's soup to nuts how to use SageMaker at scale. Let me show you the final conclusions here, or the final wrap-up items is that, let me show you something that is really easy to make a mistake at. If we go here and we go to the training job, endpoints here, and look at these endpoints, notice that these endpoints right here, they're still running, and you're going to be charged for them unless you delete them. There's 2 ways to delete them. One is that you can delete it in code, and the other one is you can delete it from here, right? So I could go here and I could delete. Also, let me show you one other confusing thing is, if you go to EC2 here and you go to instances, look, they don't show up under instances. Only my Cloud9 instance runs, or my SageMaker instance that I'm using right now shows up. My Cloud9 instance shows up, but SageMaker itself is outside of here, so it's really easy to forget about these and get charged. So the way I would clean them up is I would go through here and run these last lines of code. So shift return, and this will send a notification to SageMaker that now look, these endpoints are now done. So the final step here is I'm going to go to my notebook and I'm going to go to this demo and I'm going to say stop. So now once I've stopped the notebook and I've cleaned up the endpoints here, now I don't have to worry about being charged. But this is, let me just reiterate like the 3rd time, is those are the ways that most people get charged for SageMaker, is they go through, they do all these steps, but they forget to stop the instance, which we just did, or they forget to clean up the endpoints. And this is really important that you do those steps every single time you train SageMaker.